Start it back up. All right, so here's what's going to happen in the lab. And I don't know, I had a little half sheet space to describe what's going to happen. So here's what you're going to try and do. And I emphasize try, because there's so many variables that are going to make this lab tough. So what you're going to do is you're going to grab two balloons. Okay? Inflated, you're going to find the two balloons. And your ultimate goal is to take the two balloons, suspend them by two pieces of lightweight thread, okay, because we don't want that to become too much of a variable. So you're going to have two balloons suspended by thread. With the idea being that you're going to charge the balloon. Okay, now, the key assumption is a couple of things. We're going to assume that the balloons have equal amounts of charge. Okay?
What assumption?
Well, it's going to make your life simple.
It'll make my life very simple.
You're going to assume that the balloons have the same amount of charge. So here's the idea. You've seen this. So this is why this is going to be it, because it's kind of humid. Usually I do this in this time of year because it's cold outside.
That's not.
It's 70 degrees outside.
And it's supposed to rain on the weekend. So the
Oh, really?
Come on.
That's kind of, hey, that's a dub.
So
Driving in the rain?
here's going to be the basic
No,
and it's funny,
No.
sometimes this
Not bad.
blanket works better, sometimes the KU blanket works better. I just
Yeah.
decided this. So you're going to
It's
charge
negative.
both balloons.
It's gotta be wasted.
No, it's definitely good.
Then, using that lightweight thread,
That's what usually.
hopefully the balloons like will repel each other.
That's the try.
Not working.
So that's the basic.
Oh, there we go.
Okay.
Just use
So,
Greg, just use my hair.
or yeah, or you
Yeah, he was really conductive.
Oh, that makes it cringe.
Bird, you look like a madman.
Whoa!
Yeah, there you go.
We're getting there. Now, okay. So, if you need to if you need to like sacrifice.
Now you
Okay. So, that gives a whole new like. Somebody say something.
Hello.
Hi, Brooke.
It sounds completely different going on. Okay. So, you're going to have the two balloons suspended by a string. Now, if you haven't noticed, here's the problem. You're going to have the two balloons. They're both going to be charged. If you get close at all, what's going to happen? They're
Gotta
gonna
stay
eat,
away.
and you're going to become part of the system.
Not
Okay.
good. Not good.
Oh, this is so not good. So not good.
Research.
So you're going to have two balloons charged, okay, suspended by a string over from the ceiling.
Yo,
There's a couple of schools of thought, okay, that you need. One option is that some people will tie two different lengths. They'll have like two separate strings, and then they'll just tie them together up at the top. Okay. Some people like to make just one big long string and drape it over the hook that way. How you do this, I don't care. Now, one of the things you need to take into account that we haven't had to worry about before is the buoyant force. Now, some of you
something Nathan doesn't know about.
I didn't cover the buoyant force in my honors physics. It's a very simple equation. Okay. Your buoyant force is rho v g.
Is that technical?
It is in terms of the lab. It won't be on the test. It will be in terms of the lab. Okay? So, in terms of this rho vg,
I don't know that.
listen to me very carefully. That is the density of the fluid that is displaced. Okay?
Oh my God.
So what's the fluid that the balloon is displacing?
Air.
So
The air
I'm going to give you.
It's biblically accurate.
What?
Biblically accurate.
it's not.
Definitely.
I read it. Looked at it.
That's like saying, oh, it's a dirt molecule.
Yes.
Already in Genesis.
What do you call it?
What is?
I'm sorry.
Cable molecule.
What were you saying?
Whoa, that you're right.
Please.
I
Now-
know.
Molecule. Everyone.
To find the buoyant force, what else are you going to need?
Gravity. Volume.
You got G.
Volume.
Volume of the
balloon.
balloon.
Oh.
Now, so here's, if you look at this, here's Hank, right?
Hi, Hank.
And let's say that Hank, kind of give this a spin. So let's say Hank and this balloon, they really don't, but let's say they're the same. Hank and the balloon have the same volume.
Yes.
Which one is going to have the bigger buoyant force? The balloon or Hank?
The same.
Probably equal.
They're equal. The buoyant forces are equal. Why are the buoyant forces equal?
No mass.
Because they both have the same volume.
Yes.
Okay?
Same air.
So the buoyant force is the same. So when you look at the balloon, the buoyant force is acting up. When you look at Hank, the same buoyant force is acting up, right? Buoyant force is the same because the volume is the same. Because force buoyant is rho v g. It is not, that density is not the density of the material. It's the density of the fluid that you're displacing. If I were to put this in water, I would use the density of water. Air, not very dense. So, the buoyant forces are the same. Now, if I let go of this balloon,
You should drop Hank.
Uh-oh.
okay, right, falls kind of slow. Even with the buoyant force, why does this fall so slow?
Force gravity lowers.
Gravity's pulling it down, right? So obviously the gravitational force is
Stronger.
stronger, a lot stronger?
No.
No, but a little bit. Okay? So, but if I take Hank and drop Hank,
Hank's fat.
what do you know about the gravitational force on Hank relative to that buoyant force? That
Yeah.
Theoretically speaking.
gravitational force is much bigger.
The balloon attracted to Hank though.
So,
He has a good point.
Did you say 2%
Shut up. No, stop.
now,
Hank said 1%.
Gavin, you tap again.
Oh, dude. I thought you were looking at me.
No. What? So here's the story. You're eventually going to need to find the gravitational force between the two balloons. M1, M2 over
R squared.
I'm sorry.
You're going to need the mass of the balloons. Okay, now here's what I want you to think this through. I'm going to have an electronic balance back there that's going to measure in grams. And you're going to take that balloon and you're going to put that balloon on that and you're going to find the mass of the balloon.
You got into force buoyancy.
Okay? So here's my question. When you find the mass of that balloon, let's say it's, I don't know, 14.7 grams, whatever that number is. Okay? Is that the true, I don't want you to answer this, I just want you to think this through. Is that the true mass of the balloon?
No.
Okay? What did I just say?
Shut up, Gavin.
Settle down.
What did I just say?
I don't.
Yo, take this bounce shot.
I'm gonna be honest. I don't know.
He said, think about it and don't open your mouth. Now he said, what is it?
What did you do?
I opened my mouth.
What did I tell you not to do?
Are you going to do it again?
Yeah.
So, you need the true mass of the balloons. What you put on the scale, 14.7 grams, is that the actual mass of the balloons?
No.
He said not to answer, bro.
Then
We need that freshman chart right now, Mr. Burkham.
Yeah, that's a double.
Imagine this. You take that same balloon, put it on the scale, and you remove all the air around it. What would happen to the reading on that scale if you could remove all of the air around that balloon? Not inside of it. What would happen to the reading on the scale if you could remove the air? Okay? No.
Something happened.
I just want you to think about it. Okay? So here's what you're going to do. You're only going to hand in one write-up per group.
Oh boy.
Okay? And like I said, I got to print those out. I don't know what happened to the sheets of paper that I had. There's a whole bunch of things that you need to find. Like you need to find the charge on each balloon. You need to find the number of electrons that were lost or gained from each balloon. You can assume that the balloons are negatively charged, by the way. Okay? You need to show all of the calculations to get to that point. You need to determine the gravitational force between the two balloons using this equation, which means you need the mass of each balloon. After they've been filled with air, just don't take the balloon and then, oh, I'll just lay the balloon flat. Find the mass that way. No, that has to be after they've been filled with air. So here's the basic idea when you do this write-up. I should be able to take yours and provide that with another group, and they should be able to replicate your result. So you don't have to write it where a freshman can do it, but you do need to say, hey, what steps do you need? Like, for example, you can treat this as a sphere, okay? You can treat it as a sphere. Technically, it's not, but how do you find the volume of a sphere?
4/3 pi over 2.
4/3
You could use water.
Pi over 2.
Pi R3.
Okay? So, here's the tricky part. How you can find the radius.
Did he say answer?
Okay?
-1.
You need to find the volume of
Wrong class.
the balloons because you need that to do the buoyant force. Okay? All right. So, on Monday, so we're going to start this today. It's going to be due on Monday. Again, you're handing in one write-up per group. Be
Wait,
thorough
due
in your
Monday?
calculations. What are you going to measure? What lengths are you going to use? Don't have the balloons too close to the ceiling or they're just going to get like sucked up to the ceiling. You want them down a ways. Now, don't have them down to the floor. Generally from the ceiling, maybe a
3
little,
feet.
about that string length, okay, maybe a little bit longer.
It's like 4 feet right
But
now. Yeah.
here's the tricky part. You've got to charge the balloons, but yet not discharge them. Because if you overload them with balloons or electrons, as soon as you touch them to your hands, if you actually touch them,
Neutral.
the electrons are going to go up.
So if we touch it, we just need to restart because we compromised the target.
A little bit of touch is okay. Like if it just brushes off by your hand, that's fine.
We'll just
if
use
it's
our
like-
hand.
Yeah, you need to recharge it. Okay? That's also the tricky part. How do you charge them? Okay, I'm done. Let me print those out and I'll give those to you
Can I go to the restroom?
When does this do?
on Monday.